Hello, Algebra 1 students. Today we're going to look at solving some more examples of linear inequalities where you have variables on both sides, and we'll also look at reviewing some geometry from middle school in that context. Okay. So in this first one, I think we should be ready to go by now. We're solving for x, and there's really not even variables on both sides. X is just in one spot. So I think, can we put anything together on this side? No, and of course 16 is 16, so I'm ready to move stuff across the inequality to begin with. So what's the first thing I want to move? I want the 8 to move. Yep, so I'm going to go plus 8, right? So then I'll have negative 4x greater than 24. Okay, and then last step is divide by negative 4. So remember, in inequality land you have to be careful because sometimes the direction of the inequality reverses itself. Do we have to reverse it here or not? Yes, why?
Divided by a negative.
Because we divided by a negative. It's not because there's a negative somewhere there. It's because the thing we divided by was negative. So we're cutting our answer of 24 down in size, but we're also turning around our car. Okay? So this is going to be that. And then, of course, on all of these, we always want to graph our solution. So I'm going to put a little bit of points in there for scale. Do just a real quick sketch with, of course, an open circle. And we want everything up until that open circle or less than it. And we want the interval notation, just like always. So negative infinity to negative 6 with a parenthesis or a bracket? Parenthesis. Okay, so there's our interval notation. Let's do a couple more of those. So what about number 2 here? We're solving for p. 2 is 2. Is there anything I can do on this side before I move stuff to the other side? Tougher question, maybe. You could actually split up this common denominator of 5. But that's not going to make it easier for you. It's already got a common denominator. And that's usually what you're trying to get. So we've already got that. So I'm just going to get rid of the denominator right away. I'm going to chop it off. How? Yes, thank you. So we'll go times 5 on both sides. And that'll be a big idea that we pursue on fraction problems. Actually, fraction equations are real easy if you use this idea of find the common denominator and use it to chop off any fractions. That's really a good way to do problems. So we'll talk more about that as we go forwards. So that cancels out the 5 there, and we get 10 over here. And then it's a nice, easy problem similar to the first one. So I'm just going to finish it up real quick. So I have 3p is greater than 18. And then I'm not going to show my work on the last step. I'll just divide by 3. Now this time, do I need to switch it? Did I make a mistake?
No.
The thing I divided by was 3. It's not negative, so I'm good. Yeah?
So when you multiply by 5, do you not multiply the top at all? Just forget about it?
Well, remember, this whole bottom had a common denominator of 5. It's a great question, Dylan. So when I multiply this side by 5, that 5 is hitting all of it because this 5 is underneath all of that side. So it's kind of like it goes to 1 completely there and cancels out. And it's only because that 5 was underneath both things. If that 5 was not underneath both things, like if it was just underneath one thing, I'd need to distribute it to the other thing. So I like that question, so I'm just going to expand on it a little bit. So if we had this,
Then you would have to multiply by...
then the 5 would cancel here, but I'd have to multiply the 8 by 5 and have 40. Okay? So that'll be a different situation. It's a great question. I love it. Okay? So let's finish this guy up. So open or closed circle on this one. So the p's we're looking for, they can actually be 6 or more than 6 this time. Any of those p's will work. And here's the way we express our answer with interval notation. Okay? So let's do one more. Give ourselves a little bit of space. Some of these out of the way. So this guy has a left-hand side that's pretty simple, but the right-hand side needs some work. What's the first bit of work that I need to do?
Distribute.
Distribute? Yep, right here, right? It's a little bit hard to see. I wrote it pretty small. So let me make it bigger. So we'll leave that alone. We'll leave the 7x alone. But then we'll have negative 2x plus or minus 8.
Plus 8.
There we go. Okay, now am I done with that right-hand side, or am I ready to move to the other side already?
No.
What?
7x and minus
7x
2x.
and 2x.
So that's going to be 5x?
Yep.
Now I'm ready to move. What should I move?
Oh, no, the 8.
I'm going to move the 8. I'm going to stop showing my work because it's starting to get annoying. I'm just going to start writing the essential steps. I imagine you guys will still follow. So minus 8, minus 8. If I have negative 2 and negative 8, it's all negative. So there's 2 and 8. That's 10 of the negatives, right?
Yes.
So there you go. If you want to show your work, great. Last step is divide by
5.
5. So negative 10 divided by 5 is negative 2, right? Did I need to switch it? Do I have a mistake here? There's a negative number.
Negative 10 divided by 5.
The thing I divided by was not negative, so I think I'm good to go. But I should probably turn this around to read it appropriately, like so. Yep.
Do you
So
have
this
to
one,
switch it, or does it?
you have to switch it if you divide or multiply by a negative number, for sure.
Well,
But
mean,
here I didn't do
how
that.
you did both answers, you did negative 2 is greater than by x. Did you have
If
to
you
switch
don't
both?
switch it, there's like a 9 in 10 chance you're gonna mess up, Dylan, if you try to read it from right to left. I mean, like like I can read this from right to left, and a lot of kids who've done a lot more math than you guys have could do that too, but they never usually would. It's just a bad habit, kind of. But if you get the right answer, get the right answer. I don't care, right? So, good question. So open circle, less than, and then here's our interval notation for this one. I should have put it in red, but there you go. Okay? All right, so what I really wanted to focus on today, that should all be pretty doable by now, is the applications. So for instance, a couple problems like this. We've been doing translate problems for a while, but now they're going to be a little more involved. So these are more like realistic ones, okay? So this one says 5 less than the product of 4 and a number divided by negative 2 is. So what I would do in reading something like this, because it's a pretty big chunk of words, right, is first establish like where is the inequality symbol or the equal symbol? Is, right? Like it's like right here, yeah. So like let's chop it in half, like right there, and take it one piece at a time, one side at a time, the left-hand side versus the right-hand side, okay? So 5 less than the product of 4 and a number. What is that? So remember, you're just translating. So the number, which we just called x.
Yeah.
So let's say x. 5 less than, not just x, but the product of,
So 4x
so 4x.
minus 5.
Minus 5 on this side or on that side?
That.
I think it makes more sense to put it here. If you put plus negative 5 over here, that would work too, but you can't go 5 minus. That's not the same. Okay, so be careful about that issue.
Is that the 4 which one?
Exactly. Now is that the whole left-hand side or do I have more? So just like Dylan was asking earlier, it's a fortuitous question that he had. Should we put this under, negative 2 under this or this, just one of them or both of them? What do you think? The way it's written, does it imply like both of them or all of it?
Yeah.
I think it does. Okay? So there's that. Then let's do the other side and we'll worry about what goes in the middle in a second. So that's the middle part. The sum of 6 times a number, 6 times a number, 6x, sum, so that's plus, and 2. We're okay with that? So now the question is this equal to, less than, greater than, or equal to what? This stuff is supposed to be at least that stuff.
Equals.
So equals, yes. But it could also be more, or it could also be less. This stuff has to be at least as big as that stuff.
Or bigger. Okay.
I think that's the way the at least goes. If they said at most, then they'd want it to be smaller than or perhaps equal to, so that would reverse this sign. Okay? So now we've got the problem, let's go ahead and solve it, just like we did those other ones. So here we go. I'm going to multiply both sides by negative 2 first to get rid of my fraction. Okay. So now I'm going to have 4x minus 5. It's going to cancel out, just like Dylan asked on the other one. And then over here, do you guys think it needs to hit just one of these or both of these? I think you're supposed to do the whole other side. Really, it's like there's parentheses here, right? So we've got negative 12x minus 4. Yeah? Now there's one other mistake that I've made at this point. When I did the red thing, what did I not do? This should have reversed because I turned my car around. I doubled it, but I also doubled it like in reverse. So I got to turn the inequality around. If you multiply or divide with a negative number, just like there, got to reverse that sign. Doesn't matter what happens at the end of a problem or at the beginning. It's the same idea. Okay, so after that, you move stuff around. I'm gonna do that real quick so we can save some time. So I'm gonna add 12 over here, that's 16. Yep,
Isn't it negative 12 then?
plus 12, plus 12. Yep,
Yes.
good question. And then I'm gonna move this over there at the same time, plus 5, plus 5. What's 5 and negative 4? 1. There's one step.
So then divide by 16.
Divide by 16. I'm going to show that just in case we divided by a negative, but I don't think we did, right? So I think we're good to go. It's just x is less than or equal to 1/16. So I could graph that on the number line and just put it right next to 0 and shade that way with a solid dot. I'm going to just skip that to be brief today. Okay? So I think we're good with this one. Okay, so a bit of geometry, review from middle school, or perhaps you're learning it for the first time, I don't know. So we've got a triangle here. So it says on this one, the area of the triangle is less than 55 square inches. Cool? So that's what they're telling us. So they want to know two things. Based on the dimensions they've given us, the base of this triangle looks like it's 5, and the height is unknown. It's this expression 2x plus 3. So they want to figure out, okay, what could x be if the area is supposed to be less than 55? And then also, what's like the maximum the height could be? So two separate questions. The thing that matters most here is knowing from middle school or whatever what the area of a triangle is. You guys know the area of a rectangle, I'm sure. What is the area of a rectangle if you try to fill it in? It's like base times height, perfect. So a triangle is going to be less or more than that? It's going to be less, right? Like if you have a rectangle like this and you make a triangle out of it,
It's cutting that in half.
it's cutting it in half, right? So that's the area formula. That's the way I remember that. It's very easy to remember. Just like a rectangle, it's just cut in half. And it works for different shapes of triangles, actually. We could talk more in depth about it. That's not our point, though. We're just trying to figure out what x is, right? So I'm going to say, all right, the area is going to be half. What's the base of this one?
5 inches.
5. And the height of this one
Unknown.
is unknown, but I gave you something for it.
Plus 3.
Yeah, you're right, though, Sal. So, and then they told us something about the answer, like the area is supposed to come out a certain way. What did they say?
Less than 55.
So 55 is the A, right? But which way do I point it? So this thing is supposed to be less than,
So it's the L. No.
I think it's like that. Yeah, that stuff is on the small side of 55. It's less than. Maybe it'd be easier if I wrote it around in the other direction. But there you go. So I think you can use that to solve for x. Now it's set up and ready to solve. But the idea is I really need you to play with these formulas. That's pretty important stuff, okay? We'll do circles, we'll do triangles, we'll do rectangles, nothing too intense this year, maybe some trapezoids. So I want x by itself. There's some weird looking stuff over here. Somebody tell me what I could do to get rid of something first. You could, by the way, distribute this. You could like distribute it, but there's a better way. Just get rid of 1/2. How do you get rid of 1/2?
Subtract it.
Think of it like this. If you're like, I'm not really sure. Well, remember, this means the same thing. 1/2 is also that. Now it really looks like that last problem, does it not? So now, clearly, how can I get rid of the 2? I can go like that, right? So 55 times 2 is 110. Solving for x, remember, it's just like any other problem. Now you have choices. Remember, I taught you to choose here. You can do what two things now?
Distribute the 5.
Distribute or
Do inside.
Or you can divide to get
or you can divide by 5. It's your choice. You do which one you like. I think either one will be good here. Should we just distribute? That's what you guys said first, so I'm just going to do that. Depends on the problem. What's easier?
Oh,
And I'm going to subtract 15 at 95. Divide by 10. Running out of space.
what is
Is that 9.5?
Yep.
So x has to be less than 9.5.
Huh.
So for this triangle to have an area of less than 55, this x has to be less than 9.5. That's part A. So that's part A's answer. We could graph it, but I'm just not going to this time. So part B said, how tall could the triangle possibly be, given that you're still working with less than 55 for the total? Well, what's the tall part of this? What's the height part of this? It's the height
Oh, it's the 2x.
was the 2x plus 3. So for us, we know that that height,
Would we do 2 times 9.5? Or no, because that's.
No, 9.5.
so we know x has got to be less than 9.5. How are we going to use that? Not sure. Perhaps needs some explanation, some investigation. Why don't you guys try it? Take a second and see if you can work with some numbers. Take a second. I'll give you a minute. If you're watching the video now, think about how can you use this less than 9.5 thing to interact with the height and get yourself 55. Take a second. There you go. So my class has been pondering this over, and I told them to just play around with some numbers and try to think about what they're trying to answer. So this is a tougher question, part B. What's the triangle's maximum height? So what can the triangle's height be at maximum in order to maintain this less than 55? So what I did is I was like, okay, so I really need to focus on what the height of the triangle is, which is this, right? So then I said, you know what, I think I'm going to go back to the basics and think about my formula just one more time, same thing. So I said, okay, we need the area, which is half the base times the height, that's what we had, to be less than 55. So then I said, okay, we were solving it for x last time. Key is, this time you're not solving it for x, you're solving it for the height, which in other words is 2x plus 3. So I solved it for the quantity 2x plus 3. So I said times 2 times 2, divide by 5, divide by 5. And I didn't keep solving because this guy right here is the what? This guy is the height. So that says the height has to be less than 22 in order for this to work. So there is a little bit tougher problem that we need to work on getting to, because the SAT is built of about, I would say, 2/3 problems of that difficulty level. Maybe only half, but that's the level we need to get to by the time we have 2 or 3 more years of mathematics under our belt. It's totally possible to get right now, just a little bit tougher. Okay? See you next time.